morning class, we'll be dealing with the 1 mark type sums on real numbers. Alright, so we'll have numericals that will be of 1 mark type. 1 mark type. Numericals of 1 mark type. This will be part 1 of your video lecture. Now, question will be like this. Question number 1. Check whether 35 by 50. Check whether 35 by 50 will have terminating or non-terminating decimal expansion. Alright. Now these are the important questions which may come for 1 marks. So you have 35 by 50. First of all, see that this is not in the standard form. So what we'll do, we'll just put it in the standard form. 5 10 are 50, 5 7 are 35. So what we are getting, 7 by 10. Now 10 can be break as 2 into 5, 2 power 1 into 5 power 1. Now what we see that as the denominator is of the form 2 power n into 5 power n, where m comma n are whole numbers. Hence, it is terminating decimal expansion. Is it clear, this one, students? Now we'll do next question. Question number 2. Alright, question is same. Check whether only the rational number is different. 77 by 210. Alright, 77 by 210. We'll see for 77 by 210. Now we have to check that 77 by 210 is having terminating or non-terminating decimal expansion. Now how we'll be doing? We'll just cancel it. 7 11 are 77, 7 3 are 21, 7 0 are 0. Now 11 by 30, it is in the standard form. Yes or no? So what we can do, we can break it as like this. 30 can be breaked as if 3 10 are 30, 2 5 are 10. So we can write 2 into 3 into 5. Yes or no? What we are observing here is that denominator is having this 3 as extra prime factor. Alright. So what we can say that it is non-terminating decimal expansion. Now we'll write as the denominator contains power other than 2 and 5, power of 3. Alright, as the denominator contains power of 3 other than 2 and 5, thus it is non-terminating what? Repeating. Is it clear? Non-terminating repeating decimal expansion. Is it clear to you? Now this denominator is having extra prime factor, and that is 3. Because of these 3, we can say that it is non-terminating repeating decimal expansion, and in this case it was having the power of 2 and 5. So it was terminating decimal expansion. Is it clear? Now we'll move on to the next question. So now we'll have some questions for prime. This you can try. These questions I am giving you to try. 6 by 15, 13 by 3125, comma 15 by 1600, comma 129 by 2 square into 5 power 7 into 7 power 5, comma 125 by 44, 23 by 8, comma 129 by 129 by 2 power 2, 5 power 7. Then we'll have 17 power 17. 17 power 17. Okay? Is it clear this much? So these are the questions for you to try. Okay? You can try these questions separately and show it to me. I will correct it. Next we have question number 3. Express 2025 as prime factors. Now this question you have done in lower classes. This you have done it. So we'll just express it in prime factors. How do we do it? Solution. Now it's a bit lengthy. So what we can do it here. 2025. Now if you observe nicely, last digit is 5. So it will go with 5. 5 4 are 20. 5 0 are 0. Remainder is 2. 5 5 are 25. And then 5 8 are 40. 5 1 are 5. And then 8 plus 1 is 9, no? So it will go with 3. 3 2 are 6. Remainder is 2. 21. 3 7 are 21. 3 9 are 27. 3 3 are 9. So what we can do? 2025 can be written as how? First we'll write the factors of 3. 3 power 4. 3 power 4 into 5 power 2. 5 power 2. Alright, it's very simple. This question is for 1 marks. Is it clear? Next we have question number, let's say we have a question number, let's start. Alright, just one number start. Alright, keep it like this. What is the exponent of 3? What is the exponent of 3 in the prime factorization? In the prime factorization of 729. This question. What is the exponent of 3 in the prime factorization of 729? Now, when I say exponent, it means power. Alright? What is the power of that? So, how can we do this? We can break 729 like this. Now, if you see, this will go with 7 plus 2, 9. 9 plus 9 is 18. So, it will go with 3. So, we can do like this. 3 2 are 6. Remainder is 1. 12. 3 4 are 12. 3 3 are 9. 3 8 are 24. 3 1 are 3. 3 2 are 6. Remainder is 2. 21. 3 7 are 21. 3 9 are 27. 3 3 are 9. So how can we write? We can write it as like this. Solution 729 can be written as how many? 3 4 5 6. 3 power 6. 729 can be written as 3 power 6. So what is the exponent? What is the exponent? Exponent equal to 6. Exponent means power. What is the power of 3? What is the power of 3 here? 6. So exponent is 6. And follow this question. How to do? Alright. Next. Alright, so next we have question number 4. State Euclid's division lemma. Euclid's division lemma. If you remember, we have done one concept. Yes or no? Euclid's division lemma or algorithm. So what does it say? It says that given two positive integers, a and b, there exists unique whole number q and r such that a equal to bq plus r. And what is this r? This r is less than b and greater than or equal to 0. This condition. Now if you remember nicely, this is what? This is our dividend. This is divisor into quotient plus remainder. Yes or no? So this is division lemma. Is it clear? Next we'll have question number 5. It says if the product of two numbers is 540 and their HCF is 30, find their LCM. Alright, these are the questions which I am doing. These are the questions it has come in your board exams. Alright, 2019-20 sample paper plus some important questions from the model papers. Right. So if the product of two numbers is 540 and their HCF is 30, find their LCM. So how will we do? Out here, HCF into LCM. We write since HCF into LCM equal to A into B. These are the two numbers. So if the product of two numbers is 540 and the HCF is 30, so in place of HCF we have 30. LCM we don't know. So this what is the product? Product is given 5. How much? 40. So we have been told to find what? LCM. So how will we be doing? We'll write like this: LCM equal to 540 divided by 30. Now 0 gets cancelled and 3 1 are 3. Remainder is 2, 24, 3 8 are 24. So what can we say? LCM is 18. Is it clear to you all? Is it clear? We'll be using this formula: HCF into LCM equal to product of two numbers, that is A into B. Next we have some try questions. You have to try some of the questions based on this. Okay. You can search in your book question number 5, 6, 8. Question number 5, question number 6, 8. This is from exercise 1C. These questions are from exercise what? 1C. Then you will have example number 7. Then you will have example. This is already solved. Example 7. This is from the book. You can do this. Next, we move on to question number 6. What type of decimal expansion? What type of decimal expansion? What type of decimal expansion does an irrational number have? Solution. Now all of you know that irrational number is what? Nothing but non-terminating and non-repeating. Alright, so what we can say? Non-terminating comma non-repeating, comma non-repeating. Is it clear? Next we have question number 7. That will be your last question of this type. Alright, so question number 7 we have using Euclid's division algorithm. Using Euclid's division algorithm, comma, find the HCF of 105 and 120. 105. Now what we can do, we'll use the long division method to solve it out. Alright. Now a general division process, it goes like this. Always keep in mind. Whereas the method of finding HCF using this technique, Euclid's division algorithm, it goes like this. So we start from here. Alright. Now solution. Which one is small from here? 105, no? So we write 105 and here we write 120. Now if it goes 1 times, then 105. Now this will become 10. 10 minus 5, 5. This will become 1. 1 minus 0, 1. Gone. Then 105 will come here. Then 15 how many times? 15? 7 times. 15 7 times 105. So we are getting 0 here. So how can I write here? Using what we write? Using Euclid's division algorithm, comma, what we can say? Dividend equal divisor into quotient plus remainder. Yes or no? So what we can say? 120 equal 105 into 1 plus 15. Is it clear? Then we can write 105 equal to 15 into 7 plus 0. Now you see, this is our HCF. This was our first divisor. Yes or no? First divisor. This was our what? Second or last divisor. Why we are saying last divisor? Because see, remainder is 0. No? That means it terminates. So what we can say? We can say that the HCF, therefore, we can say that the HCF of the two numbers. What are the two numbers? 105, 120. What is the HCF? HCF of these two numbers, what we are getting? We are getting 15. Alright. So this is the answer. Just box it up. Now there are some try questions which you have to do based on this. Alright. So we'll have some try questions now. Try. Question number 1. Part 1, part 2. Then we have exercise 1A. Exercise 1A. This is from exercise 1A. Alright, these two questions you have to try. Those are based on this. Last question is there, one more. Question number 8. What is the HCF of 3 power 3 into 5 and 3 square into 5 square? Alright, so I have explained you in the concept section that HCF means highest common factor. Is it clear? So how do we write now? We write like this. 3 power 3 into 5 can be written as 3 into 3 into 3 into 5, and this one 3 square into 5 square can be written as 3 into 3 into 5 into 5. Now what we observe from here, that this 3 is common, so one time we will write. This 3 is common, so again one time we will write. This 5 is again common, so one time we will write. So 3 3 are 9, 9 5 are 45. So what is the HCF? HCF is our 45. So students, that's it for your 1 mark type. This is part 1, and if you like the video, please share it. Please do subscribe, and then Hope it is very useful to you. See you in the next video with 3 marks type question. Alright, thank you.